Right, we are going to spoof MAC addresses. A MAC address theoretically is unique for every network host connected to every network in the entire world. There should not be a duplicate. How do you find out what MAC address you have? In Windows, in this case.
You can check it. ipconfig.
Yeah, ipconfig/all. Because my Linux is still starting, so I went here. So this is, well, actually, this is my adapter right now, my wireless adapter that my computer is connected to, because I was testing to make sure that Linux would work, and it does. I had a setting on my DHCP server I needed to change. So wireless works here now too. And also they fixed something with the latest version of, I think when they went to 7.1, if you haven't updated your VirtualBox, update your VirtualBox to the latest one, because that seems to have fixed a lot of the issues that we were having with wireless adapters before. Because now it works just fine in here, and I could never get it to work before. Yeah. And I had trouble at home. I will try it at home. Anyway, this is the unique physical address of my wireless network card. Let's see, what else do we have here? We should have yep. This is the unique physical address of my wired network card. So every device theoretically has a unique physical address. Why is it called a physical address? Because it is, think of it as it's burned onto the network card when they make it.
Hardware.
It's hard coded in there. You can't change it on the network card itself. However, when we look at the OSI model, does anybody remember the OSI model? So the OSI model, oh, this is not the OSI model, but when we're troubleshooting networks and looking at networks, we always look at the physical layer first. Physical, there we go. So that's layer one. This is the data link. And this all works with the network layer. We don't have to worry about the transport for this particular thing. So what devices are on the physical layer? What's on the physical layer? I already gave you the answer. What sort of things are on the physical layer?
Network card.
Network card. Yep. Router has a network card. And Sonia's laptop has a network card. Alan's laptop, my TV, everything has a physical connection. Even if it's wireless, that's considered a physical connection because radio waves are a physical connection between my computer and that. But if all we have is a physical connection, how do I determine how to talk to Ansonia? How do I determine how to talk to Alan? Well, what did I just do? How did I differentiate between you two guys? Or talk to Mike?
Addresses, identifiers.
Yeah, I used like a nickname or an identifier. So when I'm talking to Mike, I say, Mike, this is what's going on. I talk to Alan and say, Alan, this is what's going on. But if I just say, what's going on? That would be like I'm sending something over the physical wire, but I have no idea where it's going and you don't know where it's coming from. I'd have to hide behind my monitor. So a physical layer only provides a physical connection. At the data link layer, our identifier is, and I'll just pretend Mike's, that's his MAC address for his physical person. Alan, that's your MAC address. So a MAC address identifies the physical device. Let's make this bigger. Identifies the physical device. So Mike's MAC address of Mike is different than Ansonia's MAC address of Ansonia. And it's different than Alan's address of Alan, and mine is Bill. So we all have different names, except that falls apart when we have two Bills in the room, but then you can't communicate if you have identical names. You can't communicate. Because if I say Bill, well, which Bill am I talking to? I'd have to have, in this case, there's Bill Loring and there's Bill Sheffield. So how did I distinguish between those? Well, I had to make up a new name. I couldn't just say Bill and Bill. So this should be a unique. Oh, that's not unique. Well, that's unique. That's a unique spelling of unique. So when my computer puts together a packet or receives a packet, how I identify where it's going on the local network is I build up something called an ARP cache. ARP is the protocol that allows us to resolve, I think it's -A. Oh, got it. So this will just say this is my server. And I don't know which one of these is me, but you don't ever see your own. Anyway, we'll just say this one is Mike. Right? That's not the right one. There it is. There's my right one. So we'll just say this one's Mike or whatever. I haven't tried to communicate with his laptop yet. So maybe Alan and then Sonia aren't on here. But if I want to talk to Alan, say I want to ping, I'm just going to use my server as an example. I want to ping ADS1. Well, how in the world did this work? The first thing my computer has to find out is what is the MAC address of that server? That's the first thing I have to know, because the MAC address identifies me. The MAC address identifies my server. So I use something called the ARP protocol to say, hey, I'm looking for this IP address. What's the MAC address? So I need the MAC address first to communicate. Then ARP says, okay, this IP address belongs to this MAC address. We can now communicate because we've now come down from the data link layer to the physical layer. And you notice here, I used an IP address. That's our unique identifier at the local, at that layer, IP address, is the logical address at the network layer. So if I want to communicate with my server, I would ping my server. What happened to my ping? ADS1. So actually, there's another step in here. We're not going to worry about it. I sent my packet to this IP address. Well, I can't send it to an IP address. I have to know what the MAC address is. So if I send it to the IP address, my ARP protocol says, oh, well, this MAC address belongs to that. Here is the physical connection between me and that. So the IP address is good to start with. And automatically the ARP protocol says, okay, that's fine. But what's the MAC address? Once we know the MAC address, then my computer knows how to send my packet on the physical wire to that specific device. It's not exact, but that's close enough. Okay, there is one more layer, and this is actually at the, well, I don't remember what layer it is. Anyway, that's at the, we'll just say it's like the 5th or 6th layer. Anyway, what else is happening when I ping ADS1? I'm not pinging an IP address, am I?
Mm-hmm.
I'm pinging a host name. And how do I get the IP address? What's the service that does that?
Mm-hmm.
DNS. So actually, I have 3 things going on. I ping the address. DNS translates that to an IP address. ARP translates that to a MAC address. And finally, I can talk to Ansonia. Right? That's how it works. But what if I spoof, for instance, what if my computer, I spoof this IP address? I spoof this MAC address and I say, well, I'm the router. If I do that, then all the packets come to me. And that's called man in the middle. That's a man in the middle attack. We're not doing that quite yet. But what we're doing is we're going to pretend we have a different MAC address. Physically, it's burned on the card. The operating system picks up that MAC address when it starts up. But with any operating system, you can change the MAC address in the operating system. And that's what we're going to do. So then my MAC address is not actually the unique physical device MAC address. It's something that I made up, which is one step toward hacking a network. So you think that's how it works. But we can get past anything if we have the right tools and know what we're doing. I don't know a whole lot of this, but I do know how to do this one. So in Kali Linux, now it's getting here. Apparently my bounce keys are disabled, whatever that is. There it comes. My shell. I probably have a couple of them. All right. So if we do IP space A, what do we get? In a virtual machine, whether your machine is connected up by wireless or not, it always shows up as ETH0. My virtual machine is running through my wireless card right now, but it's always going to be ETH0. And where did this MAC address come from? Well, this is not the MAC address on my computer, I can tell you that. I don't remember where it comes from. That was part of what I was looking up. Where's my wireless interface? There it is. So this is my address. This is my, there it is. There's my MAC address. But notice this is a totally different MAC address. Well, VirtualBox, because it is a virtual operating system, in order to communicate on the network where it's bridged to this network, my VirtualBox needs a unique MAC address. So it just makes one up when it boots up. So is it really hardwired? I don't know if it's the same each time. The first three parts are from Oracle. Yeah, or like Oracle or VirtualBox would say, these are the MAC addresses we can use. So it's like they're virtually manufacturing MAC addresses rather than burning them on. So can we change this? Sure. We run the MAC changer. So we do MAC changer, sudo, that's right. When you're doing futzy things like this, you have to be an administrator. And we're going to imagine -R means, oh, my example is wrong, isn't it? Yeah, but anyway, it's the same idea. What is our network adapter? ETH0. I probably stole the screenshot from a tutorial. What's my password? Password 01. Oh, try again. There. So for whatever reason, VirtualBox always shows up as Cadmus Computer Systems. I've never researched that to find out what's going on, why that is. But this is the same MAC address we were looking at earlier. This would be considered the permanent MAC for this virtual machine. Because each time you create a virtual machine, I think it creates a new MAC address. But what if we want to change it? Well, let's see what our MAC address is. Is it the same one we had before? No, it changed it. See, there's the permanent, there's the old one, here's the new one. So now we are, and Sylvia is now Philippine. I'm George. We have Mike is now Fortunica, and everybody has a different name. So if everybody has a different name, how do you know who is hacking into your network? You don't. You've disguised yourself. You put on a disguise on the network. Well, if you reboot the machine, it should come back. I don't think that's permanent. But let's just change it back. Sudo MAC changer, yes. Instead of -R, we do -- permanent. And that puts back the permanent MAC address. And there it is. We're back to Cadmus Computer Systems. If you're poking around on the network you shouldn't be on, which is what we're exploring, is how hackers do these things. Every packet you sent can be captured by every switch, router, or anything the packet passes through. So I could identify your computer by the MAC address. Well, if I spoof the MAC address, how do I know even what model your computer is or anything? I don't. Are you with me? Okay. So that's how you do it on this one. And it's built into Kali Linux. I don't know that that's built into other versions of Linux, but you can always install it. Let's do the same thing in Windows.